All right, guys, welcome back. So we are going to be looking at kind of word problems, but we're really only just evaluating our rational functions. So let's go ahead and dive right in. So there's an economist, and he's come up with a controversial mathematical curve, basically an equation that kind of equates the revenue that a government gets, so L of X, compared to the rate of taxation. And he says that there is a point where if you overtax that we start losing revenue. So the questions here are all based on this equation that he has come up with. So what's the initial revenue? Well, initial is when X equals 0. So where is it where the taxation is at 0? So all we have to do is go into this equation, and we're going to remove those X values, and we're going to put 0 in those spots, and then we are going to simplify, basically. So we're just going to turn around here, we're going to plug in 0, and I'm going to go ahead and do that. So I'm going to take out my Desmos. I kind of have this equation right here, and I'm going to remove these x's, and I'm going to put zeros in their spots. Make sure you put parentheses around things that you remove. Oops, sorry, other way. And I can see I got 4.16 repeating. Again, if I want it as a fraction, it's 25 over 6, so I just have to hit that button right over here, and it will tally it over. So either one of those answers is fine. So I'm going to go 25 over 6. So this is roughly 25 over 6. That's the initial value. So what would the amount of revenue be at taxation of 52? So this is where now we're going to assume X is 52, and we're going to plug in 52 instead of 0. So this is just really evaluating. So you're looking at an equation, you're given an input, and we're trying to figure out what that output would become based on that input. All right, sorry, that kind of moved off. All right, so plug it in 52, and I'm going to go back to our calculator. Again, I'm going to put a little squigglies, and this time I'll use the decimal version so you can see both of them. So we're going to plug in 52 instead of 0. And here, 52. And there's my fraction part, and I can go ahead and switch it over, and I got negative 46.1 will go 8. So negative 46.18 roughly. All right, the last one here, what would be the minimum tax rate to apply for revenue? Well, this really is talking about that horizontal asymptote type question. So remember, the horizontal asymptote looks at our leading coefficients. That's these ones, the 70x over x. So it's really looking at this. If these degrees, the little exponents, they're both 1 right now, if they are the same, and in this case they are, then you're going to take your equation is going to be the coefficient. So 70 over 1, which of course is honestly 70. So you can say it was 70. So it's really just, these word problems really aren't really meant to be complicated. They're just evaluations. You just need to know what they're asking you to do. So let's go into another one. Here's Yellowstone National Park. They've decided to bring in some buffalo. They have this equation. And again, you notice it says initial value, which is us assuming 0. The second question asks after 5 years, that's us assuming x equals 5. And then finally, what is the maximum? We would turn around and say that is our horizontal asymptote. Now be careful because this one's talking about animals. The last one was a tax rate. So you can have decimals for tax rates, but you can't have half of a buffalo. So we're going to have to round to the whole number for this one. All right. And then again, it's the same thing. We're just going to go ahead and plug in 0 for x. And then we will also plug in 5 when we get to this one. And so I'm going to jump over to our calculator in a second, and I'm going to have him do the bulk of our work for us. So I'll go here roughly, get our estimates, and then let's jump over to Desmos now. All right, so let's jump over this one. Here's the equation. Again, make sure you put parentheses around whatever you replace. So the first one, the initial value is 350. So I can come over here and say this is 350. So we initially had 350 buffalo. And we jump over to switching this to 5 again. We're not doing anything too complicated. And I have roughly 188.8 buffalo. So I'm just going to say 188. Keep in mind that this is the amount of buffalo, so I don't want to leave it as a decimal. So I'm going to say roughly 188. And then when it deals with the horizontal asymptote, again, we're looking at our leading coefficients. And in this case, they're in the back. That's where the x's are. And we have 30x over 0.5x. Again, we have matching degrees here. They're both 1. So our equation is going to be 30 equal 30 over 0.5. And then, of course, I'm going to use my calculator and get my approximations. So 30 over 0.5 gives us 60. That's a nice whole number, so we can go ahead and say 60. We have 60 buffaloes max before they start dying off, or, you know, it kind of gets into a circle. So anyway, it should be nice and easy. Hopefully you guys are good. Make sure you get onto Canvas and give yourself a try. Thanks.